nights I don't care if I'm right. Let's just buy a bit more time. I live alone with you inside my mind. We would dance the night away till the morning light. Can I give you all of my love till we dance the night away? Can I give you all of my love till we dance the night away? And we give you all my love, all my love, all my love. And we give you all my love, all my love, all my love. Yeah, yeah. And we give you.
Every time we say goodbye, they all see that it's a lie. 'Cause we always give it one last try. Yeah, you've watched me break 1,000 times. Now I'm all alone, 'cause you never show. You say you will, but then you don't. That's how it goes. Don't wanna know. I'm turning off my mind so I get by. I just wanna be happy, happy tonight. Happier tonight. Happier tonight. Can't be waiting for you in the morning. I'ma leave without giving a warning. I'ma leave without giving a. But every time we say goodbye, we all know that it's a lie. Now I'm all alone, 'cause you never show. You say you will, but then you don't. That's how it goes. Don't wanna know. I'm turning off my mind so I get by. I just wanna be happy, happy tonight. Happier tonight. Happier tonight. Can't be waiting for you in the morning. I'ma leave without giving a warning. I'ma leave without giving a. But every time we say goodbye, we all know that it's a lie. I just wanna be happy.
Won't you say why you're a stranger now? Your eyes escaping mine when I sit you down. Don't you feel like we're holding on onto a fairy tale, but the magic's gone? Been months of buffing the blushes and faking the butterflies. Wake up, yeah, I'm kicking the castle down.
Hey, okay, cool. I think that's working. Let me know in the chat if the sound is bad or music too loud or anything. So we're trying a new called Restream. So we're just trying to stream to different platforms so you can pick and choose. So let me know how it goes. And then we can start. So if you guys have been following us, today we're going to make a PCB for the drone, should I say, a drone PCB controller. Krish asked us or suggested we should do this. I am no professional drone maker. I can make PCBs and electronics, but to be honest with drones, I don't know too much. So help will be appreciated. I will use Google, of course, and things like that. But I think initially to start with the schematic, I'm thinking about using an ESP32 as a controller. I don't know if anyone has a different opinion on that. I like the ESP. I know it. So I think we're going to start off with the schematic, build the circuit, and then of course then go to the PCB. But I'm sure we'll need some motor drivers and all the things for the PID loops. So let's get started. How you guys doing? How's your Sundays? So I'm using Ki-Cad, of course. Best free software that I know about. I already renamed it drone. Open a schematic. PCB we'll do later. It's slow. So we'll have a PCB schematic. Guys, as always, if there's any questions, please just let me know. I don't mind explaining things. If there's just suggestions, please as well. Like I mentioned, I don't know too much about drones. But we're here to learn. So let's get started. So I'm going to start with the ESP, just the basic ESP32 circuit. A for components. Where is my components? Something strange. My A is not working. Is my keyboard working? Yes. There's label, A for components. Everyone happy with the ESP32? It's got Bluetooth, Wi-Fi. And I've been looking at some some Hackaday things. So something like this. So I think we'll, similar to this, explaining video. We might, like one of the community members suggested, not make it one PCB because if it breaks then the whole PCB breaks. So I just have the controller, but I think we can build this. I don't know what that's complaining about. Oh shucks. Big screen, desktop. That's what, there we go. Even bigger, better. I will make these, so what the, I'll sort that out. So whatever we create on Sundays, in this time slot, so every Sunday I'll do this. So if you guys have ideas for projects, but we'll first finish the drone of course, I will make the Gerbers available for everyone. So the Gerbers here, the schematic, everything will be freely available. I'll post it on the Discord channel, everywhere. So it's a really community project. That is the plan. There's the famous ESP32. So if you're not aware about the ESP32, so the ESP32 is basically a chip like this. It's got Bluetooth, Wi-Fi, everything inside. So Bluetooth, Wi-Fi, not a bad price, about €3. I've been using it for all my projects. I really like this chip. You can put Arduino IDE on it, so it's quite nice to work with that sense. Playing some Nautica. Oh shucks, you know, I'm not playing some Nautica. Carrie did the restream stuff, so I don't know what she did there. I don't know if she can fix it. Otherwise, we're playing some Nautica while making a drone. I'm sure there's some drones in some Nautica. Cool, so basically the schematic is just all the symbols. Oops. So all the symbols you can see that the I open, so that's input output pins, TX, RX, communication. Then I've got my SPIs and my all that enable VDDs, the power supply. So the SP32 can handle between 3 volts, 5 volts. Things like that. Yeah, I hope so, Venom. But you work for a company in builds drones, right? So you need to help. So yeah, so we're gonna have to program it as well. So we're gonna have to need a USB to serial converter. I always use a CP2104. Guys, as well, if you guys have better suggestions, please shout. I'm always just do what I'm used to. So this is just a chip that will take your USB signal, make it to a communication protocol that your ESP will understand, so you can program it. To be honest, I cannot remember all the circuitry out of my head, so I will use Google. I'll just make this a bit bigger. Page settings. A3. Venom, this is going to be a simple drone. So I've got to show it somewhere. So something small like this, just to play around with. So you can see they've got the ESP as well, I think, on here. So we'll try to make something like this. But then of course I'll share everything with you guys so you can order it yourself, build it yourself, all that fun stuff. Someone has built it, so if someone has built it, we can build it. Okay. So what's going on here? So we've got, so I'm just basically going to put all the components out, what I think we'll use. Please guys, as I mentioned, just tell me. Hey Krish, we need a USB. I'll probably use a USB-C, USB-B. If you guys have Ki-Cad open with me, and I'm going too fast or anything, just stop me, we can build this together. That's the idea. Hey, Vipin. If I say your names incorrect, please excuse me. Okay, so we've got the ESP, we've got the USB. I think the hardest part will be the motor controllers that I'm not too sure about. Enable. We're going to need a voltage regulator, so from the USB. Let me use the mic, I think. Voltage regulator. Very smart out. What type of voltage regulator do you guys like? A 3v3 voltage regulator. Battery charger, I normally use the MCP battery. Trying to memorize everything off by heart. Battery charger. MPU 650. What makes that one so nice? There we go. So I normally use these bad boys. Single cell. So that's my battery charger. So we're gonna have a battery, of course. MPU 650. Let's see what that's about. Oh, that's a accelerometer. Okay, yeah, we'll need that as well for the PID loop. I was more worried about the regulator as well, but I'll keep that in mind. Yeah, that's a gyro. So that you'll use that for the control system, I assume. Guys, if I use terms that you don't understand, like PID and control system, just stop me. I'll be happy to explain some concepts, and there's people on this channel that probably knows more. They can also tell me if I'm wrong or right. So yes. Okay, so I'll use that for the gyroscope, but I'm looking for voltage regulator. I use the mic. Cut the background music if I don't mind. Of course I don't mind. Is that better? No, wait. Yeah, is that better? So is it better without music, or you want some music at the back? Otherwise you're just going to look at me and have nothing. I'm just looking for a simple voltage regulator. Mic, yeah, it's ugly. That's one I normally use, but it's not that footprint. That's ugly, man. Make 521 now. There we go. That's better. So we need a 3v3. 5 milliamps. Hey Lux. Yeah, so you just have to have a look, because this, so you can see it's 500 milliamps. That's fine for the system, but there's no ways you're gonna have to need a different supply for your motors, and I assume we're gonna use servo motors. What motors do we use for drones? Servo, steppers. So we've got the charger for the battery, we've got the voltage regulator. Will you make a separate PCB for the transmitter? Can you not use the Bluetooth or Wi-Fi from the ESP, or do you need to use RF? Venom, the 4 motors to make this thing fly. What type of motors are they? Aren't they servo? And then we've got where's that EDU? I wonder if Ki-Cad has this. Oh, Ki-Cad. I like when Ki-Cad has stuff. Yeah, it's got it, man. 650. That's there. Boom. Yeah, we can control it through an app. I don't know. I haven't thought that far, to be honest. I'm just thinking about the hardware at the moment. Which app we can use? NRF is Bluetooth as well, isn't it? Venom, yeah. Thanks, man. Probably use brushless then. But then I need some way of controller with the H-bridge or something. NRF 2.4. I'm just looking at the NRF. Isn't it just a microcontroller with Bluetooth? What's different between this one and the ESP? Oh, it's what? 2G, sorry. Oh, let's check. But then can I not just use this instead of the ESP? Yeah, I'm open for suggestions. So we can use Arduino with it, which is nice. I have to draw a tenor. Other one's built in a tenor. This 2.5G, is it RF or is it Wi-Fi? Because if it's Wi-Fi, then I can use the ESP. Nano. No problem, Venom. No problem, Venom. Okay. So how are we going to control this, the brushless motor? I know we can use an H-bridge. Let's check. Yeah, Krish, I normally, it's just because I like it, but I normally play around with the ESP32. So it's basically this chip. So it's got Bluetooth and Wi-Fi, everything underneath there. It's got the various gauge as well and the tenor design already. So we can use it as well, I think. So we can control it wirelessly, there's no problem. We will just need another circuit to control the motors. So then the ESP will send a signal to this motor driver, because you'll have to control the motors, I assume, to get the balance perfect. Which driver do we use for brushless motor? See, there's some backwards. And then we're gonna probably need these brushless heavy batteries. It's gonna be interesting. Yes, I'm seeing Twitch chat. Venom's chatting on Twitch, and you're actually chatting on YouTube. It's quite cool. Are you gonna make the PCB and flight controller? Yes. Flight controller, you mean the PID type of thing to make that actually fly? I assume so. Or maybe there's someone who's done it already. How do I put the chatting overlay? 4 times EC controllers. I have no idea what EC controllers are. Electronic speed, okay. Arduino, so boom, there we go. If you see Arduino, that's where you want to be. What, are you going to do it now, or when are you going to do it? PDB. I think we're going to have to do both, because of course my ESP and circuit now will not have enough power to put the motors on. Pixel, yes. You guys are knowledgeable. What is this? Is this a model you buy and then communicate to, or is this a whole thing? How will I integrate my PCB to this? Or is it a standalone? Can't I just use where are we now? how you control it. So we can just buy these modules and communicate with it, right? Oh, awesome, Krish. So it works better for you Twitch than YouTube. Good to know. But now can't I just use my PCB and talk to 4 of these ECSs? It looks like it, right? I have a specific signal. And then I use my gyro for feedback, what position I'm in. Sure, I can use this. I think this is a good way to go, just to start with. What do you guys say? Because I can buy it, it's literally just one signal I need, which is pretty cool. And then we'll write code to make this fast or slower, depending on the position of the gyro code. Of the UDM, which one do we choose? MPU. We're probably going to need more than one, won't we? Different positions on the board, is one enough? So we'll have a connector. Yeah. So I'm just thinking out loud. So if we, on the PCB, just have a connector for one of these. Yeah, Harika. Yeah, we'll need 4 of those. Don't you get an onboard ECS? PCB mount ECS? I guess not, because it's got a ESC. Yeah, you see, if we have to make this ourselves, it's a bit different. Let's not reinvent the wheel too much. This guy has the same problem as us. I think we'll do that. Or buy 4 and 1. Yeah, let's see. 4 ECS. Yeah, stuff. You gotta love Google, eh? I just like pictures. These. Yeah, you see, we can make one of these, but that's a different, high power is a bit different. Might be fun. But for now, let's focus on the control board. So the control board will have to set signals out to this. So I think let's use this 4 to 1 or 1 to 4 or each. Oh, nice. So everyone's happy with the ESP32. Yeah, we can change it as always. I'm just going to text it so we can see. If people come in a bit later, they know what everything is. Okay, how long does it take? Can't we just quickly do it? ESP32. Krish, I'm going to make the Gerber files available for everyone. So everything I do on Sundays will be available. I'll send Gerbers, I'll send Schematic, If we do some programming, then of course that as well. Everything will be open, free, open source, whatever you want to call it. I'm just labeling it in case someone comes later to the stream, and then we all say USB. Maybe Git repo. That's a good idea. I think we should do that. Because then as a community, maybe we can work on the code and then everyone can build it. That'll be awesome. That's a very good idea, a Git repo. So if no one knows, a Git repo is basically just a way to store software or programs, or actually any files if you want to. But then as a community, you can check it out, check it in, and you can actually see what changes has been made. So if I program something, someone else can check it out and then fix my mistakes, and I can see where they fixed it. Like part of GitHub, that sort of thing. Sure, what did I do now? That's what we have so far. ESP. Of course, later we'll do the electronics. Just want to get all our components, what we need for a drone controller. We'll need connectors because we want to talk to this ECSs. Be sure that the range of the drone will not be too much, but it would be much playful. Yes, I'm not expecting it to be, the range won't be too much, but it's more for playing your house, just to get into it. We can always add, maybe that DWM 101, that's got RF. Maybe if you add that later on, you can get a better range. The ones that we use for the corona beepers. Okay, so we want to, there's a lot of stuff here. We can always buy one of these. These are pure input voltage. What does it need? So what does the ESC need to operate? It needs voltage. I need to give it a signal somehow. What signal can I give it? Let's see here. So it uses a PWM signal for RPMs, 50 Hertz. So here they're using potentiometer just to control the speed of the motor. What's this line? Look at the 5-inch drum kit. 5-inch. What is that in millimeters, man? Yeah, so electronics, speed controllers, ECS. But I'm just seeing how they actually, what type of pins do I need to take from the ESP, or what sort of communication wire should I take from the ESP to the outside world to control this? So these signals, so these PWM signals needs to be generated by my ESP to control this motor. So I just want to know what the green, red and black actually is. Oh, nice big. Maybe seen the code. PWM. There's a library for servo already. Amazing. Can just use that. So this is basically what I want to do. Krish, what do you mean by another ESP? So I will need 1, 2, 3 connectors going to the outside wall to communicate with this. So we'll have 4. No problem, Venom, enjoy. So 3 connectors, 4 of these. So we'll need about 12. But the DSEs probably come with a generic plug. I think I can use the same ESP, can't I? Hey Arjun. But that will, Krish, that will then be a different PCB at all. That will be a different PCB if I was to add a joystick, which is a good idea. The joystick, of course, can't be on the board that's flying. But then I wonder if there's just a controller you can buy that's Bluetooth, and then. But yes, that should be another project to make a joystick controller. ECS. I need to focus now. ECS connector. So I want to put these connectors on the PCB. Not these. PCB mount, PCB mount, PCB mount. Can't be those, right? Because I got 3 wires, these. No man. So I want these ECSs come with the connector, I'm sure of it, that I can plug in somewhere. So I need that connector to put on my PCB. Like there, that one. Oh, that just looks normal. JST, no. Yes. It's just a normal old-fashioned one. I can just okay. So we're gonna have connectors. 3 pin. So 0301. There we go. R is for rotate and X is for flip. R rotate, X flip. M, you can use M to move. These are the electronic speed controller output. So what is the output actually? Let's have a look. Sorry. Oh, it's actually input signals, right? Not output signals. It's got input, output. We want to control the input. The output will go to the motor. Prime is V5. Oh, there's 5. That's very nice. But I only see V4. There's V5, but it's on Etsy. It's not that. Let's have a look at V4. It's very nice. Yeah, we want those connectors. Why so many? Why so many? Okay, H bridge, I understand. ESP12, 9 axis. Oh, okay, so they actually put the H bridge and stuff on the board, so it doesn't need the yeah, so they've got the power electronics on the board. It's neat. It's very neat. What is this? What is it? 64 euros. That's not a bad price actually for this. Unibus, that's probably a protocol. ESP12. What's Bluetooth X? You showed me this, yes. Yeah, I see they also use the ESP32. Is this the same company, I hope, because this is very similar. I wonder if we should add the power electronics on the board. Bluetooth X has the okay, I understand. Yeah, you program it through their own things. Yeah, I don't know if we make it. If we want to make this small, we might struggle to get away with the electronic speed controllers. I think they're quite bulky, right? Let's see if we can add it. Is this not copyrighted? We might actually just build this. It's very neat. Very, very neat. But I wonder what they did with these connectors. So there's one for each motor, so can they have 8 motors? Hey Arun, no, we want to build a drone PCB, but now we're thinking about, are we going to just make the PCB speak to the ECSs, so 4 separate ECSs, and then my PCB will just control that? Or are we going to put the controlling circuit on the PCB as well? Because then you need some power distribution and stuff. I'm just thinking, like this one's nice and small, it's got the motors, it's got the H bridges that's required. So we can try do this, just need some bigger MOSFETs. We just use a bigger battery. What do you think, Aryan? Which one should we do? Should we just put everything in one small PCB, or keep it simple and just make a brain? Hey, Crazy Daisy. If we're going to do something, we do it properly, I guess. So let's learn together. See, so they've got MOSFET drivers, and it's probably quite high current. H bridges, one for each motor. That's fine, that we can put on. I understand that. But I wonder if they can have 8 motors. Why do you have 8 connectors? Keep it simple. Keep it simple, stupid. Kiss. Okay, so let's. I think what we do is, let's make a brain PCB to assume we're going to control an external electronic speed controller. Because then if we want to make another board with the controller, we can just like, what do you call it? Daughter board it kind of thing. Stack it. So it gives it a different control. Okay, so hey, electronic fluke. So you think we should keep it less, then we have less weight, which is true. It can't be that difficult with H bridge, right? Ah, Krish, I understand. That's clear. We're gonna keep it to 4, right? How complicated to make this? This is a simple 4 copter. Let's keep it simple. We can always expand there. So let's just keep 4 connectors. Keep that to the motors. Yeah. Like I've got the thing, if you want to do it, just do it properly, right? Because let's do it. Let's keep it small. We can Google H bridges. We can Google MOSFET drivers. Should not be too bad. Let's do it. 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 Flip a coin. No, wait. Just flip a coin. Let's see what happens here. Flip again. Okay. So heads, we keep it simple. Tails, we're gonna build everything on one PCB to control the motors. So tails, complex, heads, simple. Oh, okay, cool. We're gonna do a complex, I guess. Oh boy. Okay, so we need H bridges as well. Anyone know of any good H bridges to control brushless motors? What is this? LMN, is it? I just like to go on my local thingy. I think the LM something, H bridge. Oh, this is in Dutch, so damn it. Yeah, I used one of these before. Doesn't really matter which one you use, yeah? Or does it? I would like to keep the footprint soldering easy. L298. We should get the chat here. Gary, can you make the chat appear? Wherever you are. Don't forget you can change your mind for the purpose of keeping the design simple. Perhaps objective is for learning, so simple module might be better. That is true. So I'm just reading out loud because we got some people on Twitch, some people on YouTube, and yeah, the chat will only be on what platform you are. We didn't think about that. For the purpose to keep it simple. Yeah. It's just the H-bridge, man. It's just the H-bridge and MOSFETs. We can do this. We can do this. We can do this. We don't have to populate them. We can make a thing. So let's just get an H-bridge. Guys, who knows about a good H-bridge? So H-bridge is just a controller that controls a motor. So you can control a stepper motor or brushless. So I've used this when I built a linear inverter pendulum. So I used this one. Similar, shall I say? Yeah, L298. Oh, that's just a heatsink, man. Is it? These ones don't have this massive heatsink. They just have normal HP circuits. HP drivers. It's strange that the electronic speed controllers are so big, but you can do the same with such a small circuit. It's quite impressive. Yeah, this is just a heatsink. Spark fan. Let's get an H-bridge. When there's so many chips in the world, there's an H-bridge. LM293D. Man, min cost. What does that mean? That will probably mean try to get everything on one PCB, because I think once you get the electronic speed controller separate, it'll get more pricey. So yes, because like I said, I'm going to send the stuff to everyone at the Gerbers. So you guys can order it, make it, do what you please with the BOM, with everything. So let's do it. LM293D. What motors are they using here, Krish? You know, these are very small. We don't need big brushless ones, right? So I think you're gonna do it. Hey guys, okay, Kerry's just gonna put the chat up.
Hey.
So
Well, I will try. I don't know if I know how.
yeah, because we got YouTube and Twitch together, and you guys can't see each other's chats.
Let's see.
So please bear with us for 5 seconds.
This one, right?
Yeah,
I think we have to
we're still learning, guys.
go and get a chat link. Oops. And then in OBS we have to make a new browser capture. Just type in chat there. And then we place that. Maybe the size will be different. Hey!
It's too big.
I know. Oopsie.
What are you doing? Control Z.
Oops.
What are you doing?
Oops.
First click.
It's because it's...
Top one.
Yeah, it's meant to be on top of it.
Yeah.
There we go.
Is that big enough?
Like, put it, I don't know. Ask people.
Okay.
It's big enough.
Is that the size fine, guys? I think everyone should see everyone's chat now.
Or you can change it, I think.
Yeah, I'll change it if it's too big or
Bye.
small. Just a minute. So, where are we? Transistors, small one. 820 cordless motors. What are they? What are they? Guys, I'm learning new motors, new everything, yeah? They're so small, they're so cute. Ah. But they're still brushless. Oh, they're brushed. Ah, thanks, Aryan. Now you guys can chat. Okay, we're gonna make it small so it doesn't need a lot of power. Yeah, this is perfect. This is perfect. Okay, so done. Done. I wonder if I can do this. I'm gonna try something I've never tried. But if Ki-Cad is as good as I think it is, or good for being free, can I do this? Does anyone know if I can do this? Oh no, I can't. No. Guess I can place an image. Didn't want to do that. Just so you know, it gives us an image. It is nice. Let's just put it in downloads. There we go. That's so cool. Okay, I'm blocking. Tell me if I'm blocking stuff. Yeah, that is better. I can't go bigger. Oh, I can. Boom. That's too big. Okay, so we've decided on motors. That's amazing. Thanks, Krish. Aman, that's a good question. Not thought that far. We are soon going to find out. Depends on the H pressure and power source, I assume. So if I go with the, let's see what this one is capable of. Motor driver. How fast does it have to go? That's a very good question. What RPM is needed to get this thing off the ground? Oh, let's see what this is capable of. It's only 3 amps. So, look at the motors, right? The motors will have RPM rating, and then we can check. Where's my motors? There we go. So 53,000 RPMs with 5 voltage. But I think we can have 3 volts. Is 31,000 RPMs fast enough? I wonder. I'm sure it is. If the other people are using this, it should be fine. Yeah. I think I'd rather use 3 volts because I've got a voltage regulator. The battery is 4.2 volts. Can I use a normal LiPo battery, or do I need the special expensive big batteries? Brush motors. Okay. So 31,000. There's your answer. A bit more, so I'm going to use 3.3 volts. So this is going to become my motor connectors. MOSFET. That's a nice overview, so you can just see what we all have. I want to make sure we have all the components before we start making the schematic and everything. Hobby power. I just wonder what the circuitry looks like. It's quite cool. Not this one. Yeah, it's just the diameters, power input. Okay, we must be careful now because this one says less than 4.2 volts, but the other one said 5 volts. So I can use a LiPo battery. I always use that. I think this will be fine. Depending on the size, will probably depend how long it will last. I think we can do this. And of course, I am gonna use the internet. A small camera too. Didn't you say you want a cheap? Who said they want a cheap? You were the one who said cost, and now you want to add a camera? I'm sure we can add a camera. What am I doing? I just want a simple control circuit. I don't want to get too complicated. So you're going to put an input, you're going to have an output. There's a test circuit though, so there's your motors, your PWM there, and this will control the motors. One, two. Let's see. Can I use one chip for 3 motors? Lessons, always use lessons. So that's basically what you want to do. PWM, okay, understood. Okay. Does anyone know of a good camera we can put on, or camera circuit where we can just do stuff? Makers. Nice easy chip. You can run 2-phase motors, but we don't need 2-phase motors. Simulation of the H-bridge. That's nice. Can I switch? No. Yeah, I think we're going into much detail here. Don't want to get too complicated. Basic circuit. Let's just basic. Quadrato. Same page. So that's basically what we're going to do. Enable import motors. Sure. Old school. So we can control 2 motors with 1 chip. I think we can control 4 motors with 1 chip. Yeah, that's just the code. Not needed now. Okay. So be it. A diagram of what I have? So I need 1 chip. Is that what you guys telling me? That's amazing. So why did they have 4? Just for the heat distribution. 1, 2, 3, 4. So they probably have 2 motors on each one, or it might be a different chip, right? Okay. Oh, cool, Aman. Do you suggest we use this L293? I used it about 9 years ago when I built the inverter and pendulum. But yeah, that was just a bought-off solution off the shelf. And the air controller, yeah, also it's a different motor, I think. Cool. So we got VCC. What am I doing? That is my input. VCC of the motors, so we're going to have 4 volts. maybe I should do kit 2 and just do 2 on the motors. Or 1 inch, I don't know. Good question. I'll think about it. And then we've got 4 motors. These. I'm going to move the picture here. L293. So this is where they just connect to the motors, some capacitors. Hey Arshad. Arshad. Again, sorry guys if I say any names incorrectly. Do I need a heatsink? It doesn't matter. Thanks for coming. Aman, do you think I need a heatsink? We're not going to use that much power, or do we? I wonder. We're using such a small motors. Do I really need a heatsink? Yeah, I'll see if I'm going to drive 35 volts then maybe. I don't think we need a heatsink. No. But please, if I'm wrong, please let me know. Brushed motors. Where do I cancel this? I'm gonna get viruses. What is going on here? So there we basically have 2 motors. So this is basically what we have to do. Yeah, I think so too, I should. I think I'm just going to use this motor AB, UWM, right motor, left motor. So I'm going to use 1 chip for 2 motors. So I'm going to have 2 chips. Yes. Yes. I like these symbols. I've got everything inside. So we need 2 of them. To make wires, you push W. So you got VCC 1 and 2. So VCC 1 is the power of the chip, and then VCC 2 is the power that you want to send to the motors. That's my understanding. But these motors, as we saw, can run off 3.3 volts, so they both can have the same. I must just be sure that my voltage regulator instrument is not working. I must just make sure my voltage regulator can output enough current. So this one we chose is half a milliamp. Oh, half a milliamp, that's nothing. Half a amp, 500 milliamps. And that's not good. Or it might be, I don't know, but it's not a lot. Thanks, Ashad. I think because it still says Plumpod Adventures, and we actually changed it to Plumpod Official. Yeah, I'm not too sure where to change it now, but doesn't matter. So if you go to Instagram, it's Plumpod Official Plumpod or something like that. We'll fix it. Thanks for telling us. So I think the motor and the chip can run the same voltage. Yes. No. I'm lying to you guys. So VCC1 is the voltage of the chip. Yeah, and then VCC2 is the voltage of the motor, but then that voltage of the motor I will just take directly from the battery, and then the VCC1 on the chip I'll take from my voltage regulator, which is here. So the voltage regulator will take my voltage from my battery, which is 4.2 volts fully charged, and then make it 3.3 volts. Yes. If I talk nonsense, guys, please stop me. I'm just speaking out loud. So yeah, I'm gonna add of course I'm gonna add the decoupling caps and all that stuff. Maybe we should start slow. So maybe we should start, let's first get all our components ready. So we've got our H-bridge, we've got the motor connectors, we've got a voltage regulator, charger, accelerometer, our controller. What are we still missing? Is this a 9-axis? I see everyone's using a 9-axis. How many axes is this? So this chip, Krish told us we can use 3 axes. So I wonder, is that enough? Can we just add more then? Oh, I hope that's not the packaging. I don't want to solder that. I guess we can. I would try to keep the soldering a bit easier so that we can share it with everyone. I've got a reflow oven at home, but so that helps. World's smallest? No. They all look like this. These nice. When it ever says world's something, then you know it's going to be expensive. But maybe MPU has something else. Maybe TDK, 6 axes. I'm going to put 2 on that one. You can't have too much. So what this is going to be used for is going to be feedback. So we must be able to send information to the motors. Then the motors are going to make my drone fly. And then we're going to have to know how's the drone flying, because there's no feedback from the motor. So I'm going to sense in how it is, and that sensing will then tell my controller, okay, I'm in a certain position, put this motor on, put this motor on. Okay, that's what I want to explain. My understanding is, so we've got 4 motors that we're going to make liftoff, but we need to control each one separately. And you need feedback, so you need a feedback loop. So I've got an input, something happens, I get an output, and then my input changes depending on my output. Yeah, if you're honest. So let's say it tilts a bit, I need to say these 2 motors please push harder, and that's where the accelerometer gyro will help. So then it will sense, okay, I'm a bit in the X, I'm a bit in the Y, so try to make it even. So it's a feedback to the motors, if I explain it correctly. If you don't still understand, it's fine. I can maybe draw a picture. So it's just feedback, because it needs to balance. It's gonna probably use a controller called PID. Yeah, there we go. Ha, shout with me to it. Mind, do you know PID? Hey, you discover. Let's use this 650. I think we can use it. I'm going to use 2. One might be enough. Let's see. Man, if you don't know what PID is, I'm happy to explain to you. Eh? Please, I like these type of questions. Oh, welcome back, you discover. You discover we are basically now, every Sunday we're just going to get together and we're going to make some PCB designs. No, so we're not quoting people. For us it's just about the community now. I do this every weekend anyway, so I thought might as well sit with other people who also enjoy this type of things and we can build stuff together. So that's the idea. But no, we don't quote people for designs. But if you've got an idea that you want done, we can try help with ideas and stuff. Maybe do it on a Sunday stream or something after our drone. So that's the idea, guys. So this is going to be a every week thing. So once you're done with the drone, we'll ask someone for another idea and we build it together. So we can just get stuff out there. Okay. So I'm going to start building circuits. What are you busy building? So this is the voltage regulator we're going to use. So we're just going to use a. So you can see there's just the way it's built. 5 volts ultra low, so we've got 3/3. I'm just going to pull the enable pin high. I'm not going to control it by circuit. Yeah, some decoupling caps. Quite simple. What's that motors? The motors is cordless 860. I just want to see what the current they need. It doesn't matter, it's going to come directly from the battery. The battery will supply the current. Never mind. That's good to know. Do they have a power rating? No, AliExpress doesn't always say. Can you guys in India buy from AliExpress? Where's the power rating? Power. 5 volts, 3 volts. It doesn't say anything on power. I'm sure we'll be fine with the battery. I'm sure we'll be fine. So let's just make sure we see the basic circuit of the yeah, so you can just make a circuit like this if you want to. Decoupling caps, but I would probably just give this pin 3 enable. I won't connect to the IC, I'll just pull it directly. So this is the chip. Yeah, not too expensive. See, it's half an amp. Basically, we're building hydraulic vacuum pump to load the passengers into it. I'm not. Maybe someone in this chat can help you. We're building a hydraulic vacuum pump to load a catalyst into a. $220 drum. So let's say that's about. Yeah, I don't know how much drum weighs. So let's say 300 kilograms, right? So can't you just, is there a load cell that can handle 300 kilograms, and then you just make a load cell once is at that weight to just control the relay or something, and the relay will switch with the pump. I don't know if you get that. I don't know, maybe someone in the chat can help you. I don't think that'll be too difficult. But that's quite heavy. 220 liters is heavy. Yeah, it would work exactly the same. It's just much heavier. I don't know if a load cell can go that high. Yeah, 500 kilograms. Yeah, so it should be the same principle. So I think you would just need to make you got a load cell with the HX711. You can maybe use this with that load cell. Yeah, okay, but then it's full. If it doesn't weigh the same, then every drum won't be the same, right? So, can you not sense it someone else with the volume? That's an interesting problem. But if the weight is identical all the time, it should not be too difficult. You can just control the relay. Should be quite simple. Okay. I'm getting sidetracked. Yeah, but the catalyst is different, I assume. So you will know that for this certain catalyst, the whole batch will be a certain weight. It won't be the same catalyst be different weight for each one, because then calibration will be difficult. Where are you from, you discover? Someone in the chat wants to help. I'm like searching the same. UAE. This is a different one. I'm opening the same data sheet 5 times, right? Silly. Okay, so our shot is from Twitch. So we're streaming on Twitch and YouTube at the moment. I don't actually know how to stream to Discord. I think Discord is more private. So if they don't join Discord, they can't see it. So There's some quality engineers on this chat, so I'm sure one of them will be able to do it. I think if you can just take a load cell and then with the HX or some amplifier, use a controller and then just relay it. If there's anyone in the chat that wants to do it for you discover, I am willing to help, of course, free. Guys, I'm just going to start building the circuit, so please, if there's any questions, or I'll try to explain as I go. If you guys can think of anything I'm missing, please shout out. I actually think that should not matter. It should 20 kilograms, 200 kilograms, 500 kilograms. I think the concept will be the same. That's my understanding. I think if you've done it for one. So I don't know if you want to help. You discover it is just plum pot. I wonder if I'll send it to you. But it doesn't matter where you chat. It should be all linked. Did that work? Someone beat me to it. Gary, I think. Hey, let's go. Yeah, Shad, I made, we were busy with the coaster thing to weigh your glass and then put LEDs. So we worked a bit with that. But I think the principle should be the same. I don't think it should be too difficult. It's more difficult making it nice. But you discover how many do you need? Is it a volume? Is it just for one? Do you want to roll it out for your company? What must I do with the PP? I think it's a 4.7 nanofarad, right? Hey Aryan. And what is your time frame like? What am I doing? I'm being silly. I don't like the way this is. Let's do it like this. You can't? That sucks. Yeah, that might be a good place to chat. A lot of people can help there. Kerry, can you try to paste the Discord? I don't know what to do. Oh, there we go. Ashad, are you on both? Are you on Twitch and on YouTube? It's amazing. See if I can do something. Yeah, we're gonna have to get rid of the bugs. Thanks a lot, man. Okay, so we need some decoupling caps. It's ugly. Yeah, you discover if you want to join our Discord, there's some people who might be able to help you. Just a bunch of us chatting, having a good time, bowling cool things. I have not. Tools, I assume. Where do I do that? Something I have to download? Ah, silly. When is version 6 coming out? Apply manually, you have to like go on another website and just download a skin, or what do you mean by manually? What are you busy making in Ki-Cad, Rashad? What projects are you busy with? So let's have a VBAT. We need power. It's probably probably 10 microfarads, 0.1 microfarads. It's just for decoupling. I was going to do that later, but you caught me out. I think 10, yeah, will be fine. And then we can do it 10. Good question, Aman. Come on, man. Check what out? Check what out? What are we checking out? So these C values are just the references. If you go tools, annotate schematic, it will just make all of them what are they supposed to be. Our shard is just showing stars. Stars. Oh. Oh, that's strange. Gary's probably doing something. What is it? Okay. But what link is it? I don't know. I'll check now. Search pointer Ki-Cad customers. I love open source. I want dark, so I assume I just downloads up. So I need to go here and then put it in. I want this one. Neon. I never knew about this. This is quite cool. Which one do you use? I like this neon. Let's go neon. Themes. Just extracting it. Node. Hey, you discover. How do I install this now? Let me read. So I have to go to this directory and then paste it there. Oh shucks. You make me worry. I haven't saved yet, so let me save. I trust you, Ashad. I trust you. Now I assume I go to C. User. Add data. Roaming. Ki-Cad. Make sure you create the backup first. Moment of truth. Haha, that's cool. That is so cool. Thanks, Rashad. Another question, will we be able to modify already pulled scale to switch off a machine when we reach this annoying? What type of scale? Bathroom scale? Yeah, I discovered, I think if you just get an Arduino, get a scale, get a amplifier, I actually think you can build a proto quite quickly. Yeah, sorry, I don't actually know. I've never worked with industrial scales before. Guess if you open it, then I think it will be a bit more tricky than just making your own. What's going on here? My libraries. Any people on this chat that are scale experts? We need a battery connector as well to connect the battery. This theme is so weird now. It's maybe a bit too much. I like green though. Guys, again, if you have any questions, please just say. I'm going to do the battery charger. I'll explain as I go what every pin is for. But if I don't explain something you would like to know, please just shout or type or whatever. Version 6. I can't believe this is free, Ashad. This is quite a cool program to be free. I can't get over it. I'm going to do the battery charger now. So VDD, VSS, ground. And then we've got the status. So the status is just to say if my battery is charged or not. So this is normally to your VBP. I don't like the way this layout because the state and the program has to go together. Line state and the VDD has to go together. We are building a vacuum. Yo, man. Yeah, sure. So the video will always be online. I don't know if you're part of a Discord or anything. I can send you. How would you like me to send it to you? I'll send you the link. I can send you over YouTube. You have corona. That is bad, man. Good luck. Thanks for joining. I appreciate it. And if you have any questions, please just reach out to us. And you can always message us as well if you have questions. Yeah. But Aman, yeah, just go to Discord. If you can join us there, then yeah, we can chat. I can send the links. Thanks for joining, man. I hope you see you next week again. Then it's 15 days, and then you should be fine. Oh well, I'll just do it like this. Yeah, I see you guys as bad as South Africa as well. Not good at the moment, but we'll get through it. Just want to get a resistor for this LED. Small one. There we go. It's not ideal for the symbol. I think this neon is a bit too much for me. I'm actually from South Africa, but I'm currently living in the Netherlands. So I'm working in the Netherlands. But I'm from South Africa. I need to... You said use the... Oh, that scheme is a bit too much for me. Node. Let's use Node. Let me just finish this. I didn't close it. Did I just break it? Did I just break it? Did it change? What am I doing on Ki-Cad? Not Ki. Oh, there we go. That's a bit better. That other neon was way too much. No, South Africa's still in lockdown. Some stuff are open, but not a lot. They're struggling a bit. I think the same as India. ABD, yeah, he's my biggest, his biggest supporter, but he retired too early. I was quite upset about that, really upset. And he was going to come back for the Pro 20 World Cup, but not anymore it seems. Yeah, no, he left us. He should have been there for the World Cup. So yeah, but he's one of the best. Where are you from, Ashad? We're in India. Okay, Looks ugly. Looks ugly. Yeah, sorry man, I mean we're in India. So this is the battery charging circuit. So it's going to take the voltage from the USB and it's going to charge our battery for us. B-bus. Don't like this one. Last one. Which one's the nice one? Blue, green, dark. How does that look? Deja. No. Kuta. Are they not playing cricket in here yet, are they? Because I see England and West Indies and they're all playing. I'm looking for a different theme. Let's go for dark. So now I'm just playing too much with it. I'm just gonna go back to default and then I'll play around with different ones now. I don't know which one I want. It's so cool though. Yeah, it's going to the UAE. And the Pro 20 World Cup is a bit delayed as well. So Africa's not playing anything. Yeah, I went back to the default. Okay, battery. So what IPL team do you support? Of course, I'm Royals channels, RCB. No, it's fine. As a person's used to something, then it's sometimes difficult to change. The other one was just too bright. Just too bright. It's ugly, man. Why does it look so different now? I need to move this. I can move it, can't I? I'll show you guys what I mean. Can I not edit this? Can I move the pins? Maybe if I edit it. No, not that. I want to move the pins 1, 2, 3, 4 so I can make it nice schematic, because now my stat has to go to my VDD. It gives the status if the battery's charged or not. I'm gonna stop feeling full of nonsense and just do it. We can make it pretty later. No, something's wrong. Mumbai. Yeah, JP Dhoni played there. I like them. Pollard. Some good players. Some good players. So this is just basically decoupling caps. So these values are just values they suggest on the data sheet. So if the creators of the chip suggest something, we do it. So this is actually the same as connecting this to this point. So the name shows connection. So that's important to note. So what the stat LED does is, this is going to charge my battery, but you don't want it to charge when the battery is full. So the stat LED will go off when your battery is fully charged, just to show that the battery is fully charged, and this controller will control all the charging. That is important to know. So we can make like a 470 ohm. Nice. Now we've got a program. So this program is the amount of current that you can use to charge your battery. So the maximum you can use, you change the value by choosing a resistor value. It's in the data sheet, and the max current you can push. The quickest charging is a 2.2 kilo ohm resistor, I think. Yes. So then between your program and your ground, yeah, I'll show you guys what I mean. So you see I can connect this either there, or I can connect it to another ground at the bottom. It's the same. So if I add this there, it's the same. It's exactly the same. So if ever you see the same name, it means it's connected. Need to change this. Boom. So this is to control the current which my battery charges. So depending on the battery, I guess, but the battery I normally use, I always charge 2.2 voltage. And then we have our VBAT. So this VBAT is the same here. And you guys can start thinking about other projects as well. So I think we can finish this project, let's say in August, and in September we can maybe start something new. VBAT, but we need decoupling capacitors. I'll just do it like this, so it is it's just neater. So we can have a ten microfarads. It's maybe too much. No, let's do it 10. We can actually use the same 4.7. Ashad, what badges you spoke about? You want to make PCB badges? What type of badges? F1 is zoom, F2 is out. Didn't know that. There we go. So those are the decoupling capacitors. So we got the V bus that comes in from the USB. So it's going to charge my battery. So when I plug it in to my USB, this V bus is going to charge my battery. The stat is just the indicator to say, listen here, my battery is either being charged or it's fully charged. And this programming is how you program it to how much current you want to push through to the battery. And then it will control everything in this little chip. And we just put a nice box around it. Then we know we're done with that section, and it just makes it easier. Accelerometer, we'll do that later. USB. Let's do this circuitry. So with this CP2104, you can see my D+, so that's where the USB goes to. And then my TX and RX is actually the communication will come to my ESP32. And that will program it. But the interesting thing, or the maybe irritating thing about this chip is, well, actually it's this part. The ESP32 can go in different modes. So you have to put it in bootloader mode, and there's another mode that needs to be put in before you can program it. So some ESP you buy from the shop, you'll have to push 2 buttons to manually do it. But we normally put some transistors in to automatically do that, and I'll show you guys to use with the DTR and DSR or RTS. Yes, so let's get going. So these are labels. I'm just putting them there. They are linked. So you can see D minus D plus here. So I have to crisscross, which is not ideal. It makes it look very unneat. So you can see, so D minus, so they are connected with a label. I like to copy because then I know it's connected. So again, if the name is the same, it is connected. Because you have to focus a lot on the schematic, because if the schematic is correct, the chance of your PCB not being correct is very small, because you can run a thing called a design rule check. Everyone's a bit quiet. If you guys want music or something, just shout. Okay, ground V bus, so that's fine. So this is good to go. So this is the normal USB you'll get on most devices, the micro B. So the CB204, like I said earlier, is just a IC that will take your USB signals and make it to a language that your controller can understand to program. So it's just used for programming and charging. As you can see, it's got some general inputs and outputs. We're not going to use that. VPP, I think we got a 4.7 microfarad capacitor there. V-bus. I can't remember everything, so I'm just going to Google. Hey Krish, welcome back, man. Update. Yeah, there's a lot. So UDiscover's looking for someone to make him a scale for his business, for his company. Arshad likes Mumbai Indians. He lives close to the Tejas. Aman went. He has the corona, so we wish him all the best. And how's your studying going? So basically we've just done a circuit for your 3 voltage regulator and your battery charger. So that's where we are now. Physics. What did you do in physics today? Roadrunner. Wow. Who's Roadrunner? Thanks, man. So now it's like Twitch, YouTube, get together. I still don't know who Roadrunner is. Thanks, Roadrunner. Welcome, guys. We are busy building a PCB for a drone. One of our viewers, Krish, gave us the idea that he wants to build his own drone PCB, so we are busy with that. Laws of motion. Newton's laws of motion, or electron loops. Exon files. Yeah, Electron, I see you busy with your CNC PCB magic cutter. How's that going? I see Kerry fixed Instagram. Welcome, Twitch people. It's different seeing on OBS now, because now you don't really, it's different, it seems weird. But it's cool, you guys can use emotes and everything. Newton's law. Yeah, those are years ago, eh? Every object wants to stay, what's Newton's second law? Object at rest wants to stay at rest until the external force is applied upon, or something like that. Every action has an equal and opposite reaction. Thanks, Roadrunner. I want to do the CP2 circuit. Guys, if you just joined in, please ask questions. We are busy building a drone PCB or PCB controller. That's basically what we're doing. Wonder if I can get a picture. Where is it? So we're going to build something like this. So that's the idea. So Krish gave us this. He showed us this cute, or whatever you want to call it, little drone. It's actually quite nice. So we're going to try to build this. so we can fly. So something like this. What is flat cam? So you make Gerbers with Altium, and then as flat cam, does it make it to the, what's the routing thing called? C, not C file. I don't know. CNC machine. What format does it use? I can't remember now. G files, G source, G code. I'm getting sidetracked. It's G code, right? Now it's bugging me. CP2104 USB controller. Let's see what I need to add for the circuit. I'm going to cheat a bit, guys. I'll show you what I cheat with. G-code, yes, okay. What are you struggling with? Is it where is it? So the ESP is also open source, so they give you like a nice circuit diagram just to make sure that you are doing what you're supposed to be doing. There we go. So we're gonna use this as a reference. There's my CP, there's my USB, there's my battery charger. And then you can, they normally give me the schematic. No. Vroom vroom. What am I doing? The curve is fine, the drill files all seem to have the same dimensions. Ah, that's the first time you're using that program, the flat cam. Right, where are you from? Let's do 104. Netherlands. Hey, where we also? We stay in Breda. Breda. Bro, take a break. Are you going to take a break or are you telling me to take a break? Because it seems like I'm losing the plot. No, I'm just looking for the schematic. So ESP32 gives you a schematic for all this. Now, to be honest, I don't remember all of it. I know the concept, but I don't remember. Because it's called the LOL-in32. LOL-in32. Hey, Mr. Pawn. Mr. Pawn. Pond. Yeah, I'm just on that now. How's my fruit? There's so many ones. What's his name? Oh yeah, that's cool. Yeah, that was a long time ago, almost a year. Almost a year. Found it. Thanks, Arjan. Yeah, I was more worried about the, let's download the massive size. There we go. Earlier I was talking about this. Just support you on both streams. The drone is coming along, so we decided on the components we need. So we've got all the components we can put together and then we're going to fly. Easy as that. So that's what I spoke about earlier about the automatic GPIO pins. So this is needed so you can program automatically, otherwise you have to push those two buttons. That's what, but this is what I need. So there's my CP2103, my connections. So we're basically lazy, we copy this, and then we can program it. That's just power, we've got power. Hey, they use the same charger. Woohoo! They use a 4.7K. So yes. Like I said, I'll send these files to everyone. No problem. Let's just do this so we can do it together. Make sure I don't make mistakes. Because this is the important part. But I normally use the BT something. Other transistor. It doesn't matter. Thanks, Roadrunner. Have an awesome day. Enjoy the good weather. Gotta love the internet. I have a transistor. A transistor. Alright. Yes, I have to read that twice now. I was like, well, what are you talking about? Are you talking to me? Transistor. Damn it. Yeah, you confused me now. So I'm basically copying this. I know it works. That's nice how they make the bend. I put my finger, you can't see of course. But it's pretty cool how they do this. Where's my friend Ashad? Ashad, do you know if I can do that in Ki-Cad? I like this bend. Anyway. You have a transistor. Turn the lamp on behind you. Lamp. So this is going to be my RTS. Don't know why I'm doing the same as them. I am my own person. So this RTS DTR is signals from your CP2104, and then the GPIO enable, these are from your ESP32. So this GPIO and reset has to be in a certain sequence for you to program the ESP32. So once you try to program it, the CP2104 will do some magic with your DTR RTS. It will toggle this, and then you'll be able to program it. So that's what we're doing now. So, and this is a transistor, not a transistor. So it's just a basic switch. So when I make something high, it will just go through. So when I pull this up, it opens a switch and the signal will go through. As simple as that. Come on. I'm going to use labels to connect them, so I'm not gonna crisscross like that. So I'll just use this twice. You'll see what I mean. RTS. There. And then so they are connected. I could have connected it because I'm going to do the same here. Doesn't matter. Doesn't matter. Cool. So we've got this. We'll copy paste this. DTR. And that's also DTR. And then GPI pin. So that's just a general power input output. General for peripheral, that English word. General input output. So it's on top here left somewhere. So there, so pin 25. So we've got everything connected. So RTS is connected to this and this. DTR is connected to this resistor and this top here. And that should be it. I think that's it. This. Now we have to take this and connect it to these guys. So what I do with TX, this is probably one mistake every single person I know that starts with electronics makes, is your TX and RX swapping around. I've done it many times and I'll probably still do it. So your TX of one device needs to go to the RX of the other device. That makes sense, but I've done it many times incorrect. So this TX sends information that this RX must get. So don't connect this TX to that TX. Oh, nice, yeah. If that makes sense. You see, what is going on here, man? I need a PDF, be easier. So you can see TX is actually connected to RX. So this is how they talk to each other. TX means transmit, RX means receive. I normally put a resistor in between, I don't know if they do the same. No, that's fine. So what I like to do is, I say TX ESP32, CP214. So we give it a name we understand. Now I'm going to put a resistor in for two reasons. It's just good practice, and the other one is if I ever make a mistake, I can short it manually. That's the biggest reason. So if I swap these two by mistake, then I can just remove the resistors and then solder across. If I ever do my RX and TX incorrectly. But I've made that mistake so many times, so it should be fine. 10K is too much.